Hello students, welcome to Online Maths Classroom. This is part 3 of your statistics, and in this video we'll learn about solutions of exercise 15.3 and miscellaneous exercise. So let us start with it. Exercise 15.3, number 1 is from the data given below, state which group is more variable, A or B. Okay. There are two datas given to you, like these are the class interval with marks, okay, depicting marks, and group A and group B. There are two groups A and B, and the corresponding frequencies are given, right? So you have to compare the datas and show which group is more variable, A or B. So let us see how to start solving it. So firstly I'll take for group A, right? Now marks means the class interval, then the frequencies I have taken for group A, these frequencies like 9, 17, 32, right? And the second one we will take when we will discuss group B, right? And then the mid values xi, right? And then your ui, which is xi minus a upon h, right? A is your 45, see from here, A is 45 and h is your 10. You can see here from here that h is 10. Then we'll calculate FIUI and then FIUI square. And the corresponding sums are -6, 342 and n is 150. Now first we will find the mean, right? And mean will be calculated by the formula summation FIUI by n times h and plus assume mean A, right? Or A plus summation FIUI upon n into h. So it is your 45 minus 6 upon 150 into 10, that is 44.6, right? Then I'll calculate the variance. Variance sigma x square means we are taking up the first data. So it is sigma x square variance. And for the second we'll take sigma y square. So it is your h square upon n square, like I'm taking this one, times n times summation FIUI square minus your summation FIUI whole square, right? Now fill up all the values. This is your 10 whole square, 150 square, okay? Then it is 150 n into this 342 and then minus of -6 whole square, right? And on solution I'll get it as 227.84, right? Then I'll calculate my standard deviation, which is your sigma x, and this is 227.84 root, which is 15.09, right? Similarly for group B, I'll calculate the same thing. This is my marks. These are Fi frequency, Yi mid values, and this is my Ui. Yi is minus 45 upon 10. Assume mean is 45, H is 10. This is my N. Then this is assume mean. This is FIUI. FIUI square. This is -6, 366. And the formula for mean I'll take for group B as Y bar A plus summation FIUI upon n into h, which is your 44.6. So mean is same, right? And variance is sigma y square, right? And using this formula, we'll take our, right? We'll take this one, okay? And fill up all the values as we did in the earlier part. And it is your 243.84 and the standard deviation is 243.84 root, that is 15.61. Now we need to calculate our coefficient of variation. Coefficient of variation is, the formula is sigma upon x bar into 100, right? And since our two groups are having same mean, okay, you can see the mean for both groups are 44.6. Therefore, the group with greater standard deviation will have more variability, okay? Deviation will have more variability. The one whose standard deviation is more, that group will be having more variability, or we can say less stability. So we find that group B is having more standard deviation, so, or greater standard deviation, so group B is more variable, right? As your sigma y is greater than sigma x. So this is the way this question can be done, and this is the formula for coefficient of variation, for which we need your sigma, that is standard deviation upon the mean, into 100. So we can apply this formula for checking the coefficient of variation, but if the same mean are there for two different datas, then we, by checking just the standard deviation, you can conclude which one is having more variability. So more variable means less stable, right? From the prices of shares X and Y given below, find out which is more stable. Now here this is like the one who is more variable is less stable, right? So here he has against the one which is less variable. So again the two datas are there, X and Y, and here no class intervals are there. Now for share X, this is your Xi, right? Now see, they are not arranged in ascending order. If you will arrange in ascending order, the number of terms here are 10. You will find that assumed mean will turn out to be 50. Okay, and di is your xi minus c, which is your xi minus 50. So it is minus 15 and 4 and 2 like this. Okay, so the sum is total 10. Di square is the square of these terms, which is your giving sum as 360. Then we'll calculate x bar like by the formula your a plus summation di upon n. So it is 50 plus 10 by 10, that is 51. Okay, variance is sigma x square, and I'll use the formula here 1 upon n times summation di square minus summation di upon n whole square. Okay, and this way also this formula can be used, right? So putting up all the values, we'll get this as 35. Variance is your 35 and standard deviation is sigma x is root 35, that is 5.9. Similarly for share y, this is my yi. Okay, so these are all yi's and the number of terms are here 10. Okay, now di is xi, here we are denoting it by yi, so yi minus 104. So 104, when you will arrange it in ascending or descending whatever order, you will find 104 is the assumed mean. So this is your di and this is your 10. Di square is your square of these terms, which is turning out to be 50. Therefore mean y bar is a plus summation di upon n, which is your 105, and the variance is sigma y square, and you can use this formula directly here, right? So it will become your 4, standard deviation is root 4, that is 2. Now since the means are not same, so I'll use the formula for coefficient of variation for share x, that is sigma x upon x bar into 100. This is the formula, and 11.61 is CV. And similarly for y, share y, it is sigma y upon y bar into 100, which is your 1.90, right? Now since CV for share y is less as compared to CV for share x, you can see that for y it is less as compared to x. So that means the variation is less, that means it is more stable. So share y is more stable, right? So y is more stable because x is more variable, right? So one who is less variable is more stable. Number 3 is an analysis of monthly wages paid to workers in two firms A and B belonging to the same industry gives the following results. Number of wage earners, this is for firm A, this is for firm B, right? So you are given number of wage earners. So 586 for firm A, 648 for firm B. And see, the mean is same. Mean is same for both these firms, 5253. So we need to apply the formula for CV also, right? So variance of distribution means variance here is sigma square is 100 and here it is 121. So sigma is your 10 for this and 11 for this, right? Which firm A or B pays larger amount as monthly wages, and which firm A or B shows greater variability in the individual wages, right? So see here x bar is equal to y bar, right? And each of them is given as 5253, and the number of terms with first is 586 and for second it is 648. So amount paid by firm A as monthly wages is your nx bar, right? The number of your wage earners into your total x bar, right? The average. So number of workers into mean of monthly wages will give you amount paid, right? So firm A pays n1 into x bar and firm B will pay n2 into y bar, right? So you can calculate it by multiplying also. Otherwise, since x bar is equal to y bar and number of persons, see, your number of persons in your firm B are more. So definitely you know that firm B will pay larger amount as monthly wages, right? So you can either multiply then check, or you can conclude by this way also. Also sigma a square, see variance sigma a square for Fermi, it is 100, so sigma a is 10, and sigma b square is 121, and sigma b is 11. Right, now see, since your means are same, so when means are same, so there is no need to go for CV also if it is not required, because on the basis of standard deviation you can conclude. Now since x bar is y bar and sigma b is greater than sigma b is greater than sigma a, so you can say that form B shows greater variability in individual wages. So when mean is same, only on the basis of standard deviation you can conclude the answer, right, instead of going for CV. Remark means more variability of B implies more stability in A. Number 4 is the following is the record of goals scored by team A. Number of goals scored, like this is the table like XI and FI. And for team B, it is given that mean is given by 2 and standard deviation is your 1.25. Right, mean is given as 2 and standard deviation as 1.25. Which team is more consistent? Okay, so for team B, everything is given, right? Y bar is 2, your variance is your 1.25 whole square, like because it is standard deviation, so its whole square is 1.5625, that is 1.56. Okay, and moreover, see, now firstly let's solve your for team A. So it is your xi, this is your fi, you know what to do, fi xi square, all these things. N is 25, this sum is 50, this is 130, and I'll calculate my x bar as summation fi xi upon n, which is 2. Right, and variance will calculate by the method 1 upon n times summation fi xi whole square minus 1 upon n times summation fi xi whole square. So it is 1 upon n times summation fi xi square minus 1 by n times summation fi xi whole square. So it when calculated comes to be 1.2, right? Now see, the means are same, x bar and y bar are same, right? So means sigma a square is less than your sigma b square, right? So sigma a square is less than sigma b square. That means if sigma a square is less than sigma b square, definitely sigma a is less than your sigma b, right? So this is the way if you want to avoid to go for standard deviation unless until it is asked. So on the basis of variance also you can conclude the answer. So that means team A has smaller variability. Okay, sigma A is less than sigma B, so means team A is less variable. Hence, team A is more consistent. Consistent means one who is less variable or one who is more stable is more consistent. Number 5 is the sum of squares corresponding to length x in centimeter and weight y in grams of 50 plant products are given below. This is your summation xi. Okay, this is summation xi square. This is summation yi. This is summation yi square. How many terms are there? 50. Which is more varying, length or weight? So let us see. Start for length x. No table is to be framed as the values has already been calculated. So mean x bar is simply summation xi divided by 50, which is 4.24. Okay, sum is already done. Divided by 50 will give me my mean. And standard deviation I'll use by the formula. Your 1 upon 50 times, I'll use this one. Summation xi square minus x bar square. So all the values are given like here from, this is to be substituted directly from here. Okay, and you'll get it as 0.28. Now you can go for your coefficient of variation, because here the means are not coming same. So sigma x upon x bar into 100 will give me 6.60. For weight y, the mean is y bar summation yi upon 50, which is 5.22, and standard deviation using this formula it can be calculated. Okay, take up all the values for y. So it is 1.38. So again I'll calculate when CV is sigma y upon my giving the value as 26.44. Okay, so it is sigma y upon y bar, which is missing. So I'll put here y bar. Okay, so since CV for y is greater than CV for x, so means weight is more varying. Okay, ones whose variation is more varying, right? Now let us start with miscellaneous exercise. Right, so here Number one is now the questions in miscellaneous exercise are very, very important. The mean and variance of 8 observations. See, 8 observations are 9 and 9.25 respectively. There are total 8 observations whose mean is 9 and variance is 9.25. If 6 of the observations are given, 6, 10, 7, 12, 12 and 13, find the remaining 2 observations. So this is the question. Very important type of questions. So see, 6 of the observations are here. 6, 7, 10, 12, 12, 13. Okay. So let the remaining 2 observations out of these n equal to 8 are A and B. Okay. So we know mean x bar is summation of all divided by n. So this is yours. This all these terms sum along with A and B. Okay. So this complete sum divided by 8. How much is this? It is equal to 9. It is given. So means I'll get from here A plus B as 12. The first equation number 1. Okay. Variance, the formula for variance is sigma square, which is 1 upon n times my summation x square minus x bar square, right? So sigma square is means the variance is given as 9.25, x bar is 9, so n is 8. So see, variance I'll calculate it like 1 upon n times, this is summation x square, this is my summation x square. Okay, means instead of this x, I'll take 6 square plus 7 square plus 10 square plus 12 square, all of them minus the variance, that is 9 square. So open it up, take this 81 to other side, and 1 upon 8 times this complete. I'll get from here a square plus b square, right? Now I need to get my values of a and b, so I can solve it in either way. I can use the formula like square root of complex number when we calculated that kind of formula, or the one is from equation number 1, I can frame the value of b as 12 minus a, put it in this your number 2, okay, changes to only single variable term like a square, and then you'll get a quadratic equation a square minus 12a plus 32 equal to 0, and the two factors of a as 4 and 8. So when a is 4, b is 8, a is 8, b is 4, right? So in any order means the two observations remaining are 4 and 8. Okay, so this is the way how the question is done. Okay. Now this number 2 is same, so let us take it quickly. So 5 observations here are there, which are your 2, 4, 10, 12 and 14. The mean is given here as 7, and mean of 7 observation here is given as 8, and variance is 16. Okay, if standard deviation is given, so be careful, either you have to square it or you have to use the formula for standard deviation, right? So it's better suggested that you convert it to variance and then go for it. So these are the observation. Let the remaining 2 observations are a and b. So x bar is summation xi upon n, and you'll get from here a plus b as 14. The variance formula sigma square like 1 upon n summation x square minus x. So from here also my sigma square is 16, x bar is 8 and 7. I'll put up all the values. Okay, take this 64 to other side, and we'll get a square plus b square equal to 100. Now from 1 put b as 14 minus a, and we'll get a quadratic equation here as a square minus 14a plus 48 equal to 0, and a will give you two values 6 and 8. So when a is 6, b will give you the value 8. When a is 8, other value is 6, right? So 6, 8, 8, 6 are the remaining 2 observations, right? Number 3 is the mean and standard deviation of 6 observations are 8 and 4. If each observation is multiplied with 3, okay, find the new mean and new standard deviation of the resulting observations. Okay, now let us start this question. And now let the 6 observations are your x1, x2, x3, so on so up to x6. So what is x bar? It is summation xi, where I varying from 1 to 6 means like all these sum divided by 6 is 8. So what is your summation xi? It is 48. 8 into this x bar is given here is your 8, and this 8 into 6 will give me summation xi as 48. So this is number 1. Standard deviation is your sigma x, using this formula, it is equal to 4. So that means on squaring it, I will get my summation xi minus x bar whole square as 96. Now when I'll multiply each observation with 3, so it will become like 3x1, 3x2, 3x3 and so on so up to 3x6. Now that means your yi is 3 times xi, right? Okay, so y bar is your summation yi upon 6. So can I write yi as 3 times xi, right, upon 6? Now 3 I can take outside. because it's constant and summation xi upon 6. So what is your summation xi? Okay, this is your 48. So 3 into 48 by 6, which is your 24. Right? Right? So that y bar equal to 3 times x bar. Similarly, the new standard deviation is sigma y is 1 upon 6 times. Now this is your denoted by yi minus y bar square. Right? So in place of yi, I'll write here 3xi, and in case of y bar, I'll write 3x bar. Okay, so these are the conversions. Now can I take out 9 outside? Yes. So 9 by 6 will be outside here, and remaining is your summation I varies from 1 to 6 xi minus x bar whole square, whose value is 96. Okay, so this we can take out as 12 is the required answer. Okay, 12 is the required answer. Number 4 is given the same question, and now it is in the form of your theoretical one, right? Here the observations are in AB form. Okay, so given x bar is the mean, sigma square is variance for n observations, and the observations are denoted by x1, x2, so on, so up to xn. Okay, and you have to prove that mean and variance of the observations ax1, like there it was the 3 times multiplied with 3, so here it is multiplied with a, or ax bar, a into x bar, and variance is a square into sigma square, respectively, when a is not equal to 0. So let x bar and sigma square be the mean and variance of your observation x1, x2, so on, so up to xn. X bar is your sum of all xi's upon n, and this is the formula for standard deviation. Okay, variance and then convert it to standard deviation. So I can use the formula for my standard deviation also, or variance also, but convenient is to use my variance. Okay, because it involves your square, and avoid the root, we can go by this also. But otherwise, if you are okay with it, then you can go for it also. Now each observation is multiplied by a, which is a non-zero term, so observation will be like this, and that means they are of the form a times xi, a times x1 plus x2, so on, so up to xn, right? So mean will be now the sum of these divided by n. That means, can I take a common? So x1 plus x2, so on, so up to n, that is a outside, and this complete is x bar, so it is ax bar. New mean is ax bar. Now changing xi to axi and x bar to ax bar in equation number 1. Now this is my equation number 1. So I'm changing my xi to axi like this we have done here. Okay, that yi type of thing. So a square is common, xi minus x bar whole square. So a square is outside, this is 1 upon n times this, and a square is outside, and this was your, see from here, this was sigma square, right? So similarly, if each of the n given numbers of a series having variance sigma square is divided by a, then the new mean will be also divided by a, and the variance will be divided by the square of the number with which we have divided, right? Okay, so this is also something very important to be understood. Number 5 is the mean and standard deviation of 20 observations are found to be 10 and 2 respectively. On rechecking, it was found that an observation 8 was incorrect. Okay, calculate the correct mean and correct standard deviation in each of the following if wrong item is omitted, and number 2 if it is replaced by 12. So this kind of questions are very, very important, right? If you don't get an exam a tabular question which is for calculating your mean, variance and standard deviation, the other choice is this type of question where some omission or some addition is there, or some replacement is required, right? So actually what is there, that there were 20 observations, okay, whose mean was 10 and the standard deviation was 2, and don't know what were the observations, right? So let us start the question, and you have to correct it, that I know that one of the observation I got 8 was incorrect, right? So if I have to delete that item, what will be the new mean and standard deviation correct one? And if it is to be replaced by 12, the right observation, then what will be this? So see how to do these questions, right? So firstly, the basic fundamental is that I have to firstly correct my xi, the sum of terms, and also the sum of square of terms, right? So I have to correct them, and then I will frame my correct mean and standard deviation. So see, x bar is summation xi upon n. So my summation xi is nx bar, which is 200. Now this is 200 is including your wrong observation 8. Okay, and given standard deviation is your 2, that is variance is 4. Now using this formula, 1 upon n times summation xi square minus x bar square, it is 4. Okay, now putting the value of n and your x bar. Putting the value of your n and x bar, it becomes 1 upon 20 times this. So actually, I'm getting the value of summation xi square. So what is my summation xi square? It is 2080. See, 20 multiplied here and then plus 100. Okay, so this is your 2080. Okay, now up to here things are clear that I got my summation xi also, which is 200, and this is the wrong one. Okay, including that wrong observation here, and my xi square is 2080. Now I have to make the correction whether I want to leave it or I want to replace it by 12. So first part is, now concentrate on first part, which is wrong item is 8 is omitted. Okay, if wrong item is omitted means out of the sum I have to also take it out. So means now 200 minus 8 is 192. And new xi square means from square you have to, because xi square means you are squaring the term. So from xi square you have to take out 8 square. From this sum you have to take out 8 square. So it will be 2080 minus 64, that is 2016. And how many observations are there now? 19. Not 20 but 19. So this is the thing to be remembered. Now correct mean will be your correct sum or new sum divided by n. So new sum is your 192 divided by 19, and it will give me 10.1. Okay. Now the variance is your 1 upon n times new xi square and minus new mean square, right? So your 1 upon 19 times this is my new xi square and new mean is your 192 by 19. Okay. So this becomes your 3.99 and standard deviation will be root of this, that is 1.99, right? So be careful while doing all these calculations. Okay. Now see, number 2 is wrong entry, 8 is to be replaced by the correct 12. So your corrected xi will be incorrect xi. From incorrect xi you have to take out 8 and add 12. Okay, so it becomes 204. Subtract 8 and add 12. Remove the wrong entry and add the correct one. So number of observations here are 20. So what is your correct mean? It is correct xi upon n, that is 204 by 20, and that is your 10.2. Now correct xi square, it is incorrect xi square, and again as from correct xi you have to take out the wrong observation and add the correct. So from my this I have to take out the square of wrong and add the square of right one. So I get it as 2160. Again the correct sigma square is 1 upon n times correct xi square minus corrected x bar square. So these are the values which you need to put, and I'll get it as 3.96, and the square root of this is giving you standard deviation, which is 1.99. Number 6 is the mean and standard deviation of marks obtained by 50 students in your 3 subjects like maths, physics, chemistry. Okay, the mean is 42, 32, 40.9 as subject wise, and standard deviation is also 12, 59, 20. So which of the 3 subjects shows the highest variability in marks and which shows the lowest? So see, as the means are not same, so I have to calculate my CV. So CV for maths, CV for physics, CV for chemistry, and the formula is standard deviation upon mean into 100. So for maths it comes out to be 28.57. For it, physics is 46.88. For chemistry it is 48.9, and the chemistry is having the greatest CVC and maths is having the lowest one. Okay, so hence maths is less variable, whereas chemistry is highest, showing highest variability, or is variable. Okay, is more variable. Number 7 is also very important. The mean and standard deviation of a group of 100 observations were found to be 20. 20 is the mean, 3 is the standard deviation. Later on it was found that 3 observations, okay, they were incorrect. Like it was incorrect, here there are 3 observations, and which were recorded as 21, 21 and 18. Okay, 3 observations are incorrect. Find out the mean and standard deviation if the incorrect observations are omitted. Now as we have done this part, so here we have to omit the wrong observation. So see how to do this question. So my n is 100 in this case, my mean is 20. Okay, so what is my summation xi? This is nx bar, which is 100 into 20, that is 2000. Okay. Now 3 observations which are wrong are, what are they? They are your 21, 21 and 18. Okay. So I have to correct my xi. So my correct xi will be your, I have to take out these 3. I have to omit. So I have to take out the sum of 21, 21 and 18 from this my correct xi and this incorrect xi. So that is 2000 minus 60, which is 1940. Okay, now the number of observations is also reduced, like 100 minus 3, that is 97. So the new mean is your new xi upon new n, which is 1940 by 97, which is 20. And the standard deviation is 3, that is sigma is 3. So I'll go for the sigma square formula because that is more convenient. I have to avoid the square root. So it is 1 upon n times summation xi square minus x bar square, which is 9, right? So you can go by the standard deviation formula also, okay? But it is depends upon as per your convenience, right? Which one you would like to take. So here your n and x bar are given, right? So summation xi square upon 100 minus your 400 is equal to 9. So this is my incorrect xi square, which I get it as 40900. Now I have to correct it. So what will I do to make it correct? I will subtract out of it. Right here I subtracted this term, so I'll subtract from here the square of all these terms. So I'll get it as 39694. It's a very, very important question, right? So what is correct xi? This your correct sigma square. It is your 1 by n times correct xi square minus correct mean square. Okay, correct mean whole square. So it is 1 upon number of observations are your reduced to 97. 39694 minus 20 whole square. So it is 409.216 minus 400, which is 9.216. So this is my correct sigma, which is 9.216 root, and this is your 3.036, right? I hope whatever is taught is clear to you. Give it a good practice, as this topic seems easy, but it requires a lot of memorization of formula, and you should be wise enough to choose a proper formula for a proper question. Okay, for a particular question there is a set of formula which is quite accurate. Okay, so you should use the accurate formula and you need to remember them also, right? And also the calculation skills are very, very important. So don't do these questions orally, right? You do it in written format, and in this way this topic will be clear to you. I hope whatever is taught is clear to you. Thank you so much.